Hi, my name is Leslie Rivera, and today I will be showing you how to find the polar form from the rectangular complex numbers in this unit circle. So in this presentation, you'll be essentially looking for the polar and rectangular forms of complex numbers. And just to get you through this whole process and explanation, I want to go over the unit circle that we have right here in front of you. So just to go over it, I just want to remind you of some key functions in it so you understand the video as you continue to watch it. So here we have the imaginary line, the y-axis as we call it, and our x-axis stands for the real. So as we recall in Algebra 2, we talked about imaginary numbers throughout the end of the school year. So, which consists of I, which in here we could see 3i. And we have our real numbers that, don't have the I next to it. So in this function, I put here a number 4 and a 3. So we have 3y and then negative 4x, basically. But as to recall or just remind you of the equation that we have here, we have negative 4 plus 3i, which is a complex number, or imaginary. But as we continue throughout this video, you'll see that we use the x-axis as our sign because if you recall, we have the x stands for cosine and y stands for sine. So this is why we have these two functions right here. But yeah, let's get started. Here we have the functions written down. And to prepare us, I put in the functions in this order so you could get a feel of what exactly we're looking for, and I'll lead you through what these mean. So throughout this equation, we have to figure out how this rectangular form, or how can we convert this rectangular form into a polar form. So here we have, since if you recall, we have sine and cosine, right? And if you remember, sine over cosine is tangent. It's tan. So this is why we have r sine theta over r cosine theta, because essentially it's pi. Like that's the formula for pi. So we put 3, right? So we have 3 for sine, 3 on top. And we have negative 4. So obviously this equation is negative, so we have 4 right here. And as we continue through that, we did find our tan. But now we have to find the actual like the answer to it. Like what negative 3 over 4 pi, like the inverse of it is. Or at least with the exponent. So, we have tan negative 1 minus, or negative 3 over 4. Which if you punch that into your calculator, you'll get negative 36.87. But the thing is, you need to find your pi as this is our unit circle, right? So our sign is going this way. And for us, that means it's pi 4 because we're still we have pi over here, so we have pi, and then we have pi over 2, and so on. It continues on. But we're using pi in this equation to add it to our our rectangular form answer, essentially to get the answer and convert it into polar form. But we have to add pi in order to find our this angle right here, as we call it, the sine. angle. But as what I did here, I plugged it into a calculator, and as you plug in negative 36.87 plus pi, you'll get, essentially, negative 33.73. But when you punch it into a calculator, it will be a longer form. So you could just round it up to, the nearest hundreds, and it will just use them to get this number. But this isn't the answer to the polar form. So we actually have to find the actual radius, because we never found this. We have our our x and y, but we don't have the hypotenuse, the r. Now the one here represents the one that would be right here to classify one of the numbers. Because as you move to the right and up, like, this is still 1. But in this case, we're going to disregard that because we don't need that. So we need to find r. And if you already have your x and your y, so now you could just do the Pythagorean theorem. So if you plug in negative 3 squared plus 4 squared, you're going to get 5r, which before, if you plug it in under the hypotenuse, or not the hypotenuse, if you plug it in, you'll get 5. And that essentially is your hypotenuse, or your radius, as you may call it. So you would put that essentially in the front, and repeat the process of inserting this number into the equation. So going back, you would input 5 in front, and then cosine negative 33.7 plus 5, 5 sine 33.73, negative 33.73. I. Remember, imaginary, so don't forget the I. And in order to fix the equation up, or just make it more concise, you would essentially put the 5 in front and put it in the parentheses and just continue to add the cosine, put this into the bottom. But instead of putting it at the back, you put it in the front. If you remember back in Algebra 2, they would essentially, the answer is still correct if it's in the back, but it's better if you put it in the front just so it doesn't get lost or anything, or you don't get confused. So you put the I in the front and bring down the sine negative 33.73. But this is essentially the answer you'll get from the rectangular form. You'll get the polar form out of the rectangular form from this unit circle. And throughout this video, you just had a step-by-step process of how to really look for it and how to essentially find the numbers and put them together, and how an imaginary number really works.